Hello and welcome everybody to today's lecture about protection in electrical power systems. This unit is about overcurrent protection and especially the selectivity and fault locating by means of overcurrent protection. Let's take our typical network, which consists of a transformer, a busbar and a feeder, which will have a fault. This fault is indicated by the red arrow. So, how does overcurrent protection react? In light blue you can see to my right side the tripping times, which are continuously going up from the end 0.4 seconds to the beginning of the line 0.8 seconds, to the low voltage side of the transformer 1.2 seconds and the upper voltage side of this transformer with 1.6 seconds. Now at the onset of the fault we have a fault current flowing from the grid to the fault and all relays will pick up, which is indicated by a yellow square. After the elapse of the first grading time, which is 0.4 seconds, this relay will pick up and trip, which is indicated in red. So when we look at the status of the network now, we will see that we have a pick up of the relays from left to right and the one that is closest to the fault has tripped out. So what happens for a fault at the beginning of the line? The methodology is exactly the same. We have the feeder with the fault location, the fault sets in, the current causes all the protection relays upstream to pick up, and that one with the lowest tripping time will actually trip out, indicated in red. So here we have this picture, which may be displayed in a control room. The same happens for a fault at the busbar. So again, for the busbar fault, there is a fault current coming from the grid through the transformer. The two relays which see this overcurrent pick up, and that one with a relatively shortest tripping time will trip out and clear the fault. So the final situation is this one. Now let's look at the comprehension of these three different fault positions: end of the line, beginning of the line, busbar. So this was the fault at the end of the line. We see that only the minimum section has tripped out, which is the last section. If we have a fault on the beginning of the line, we see the whole feeder is tripped out. That is necessary because all other relays would not be appropriate. And here again we have only minimum sections tripped out, and this is selective, by the way. The last one is fault at the busbar. We see that the low voltage side overcurrent protection of the transformer has tripped out, and again only minimum sections are tripped out, and that is selective. In the second part of this lecture I will show you how the behavior of overcurrent protection can be used for fault locating. So here again we see the different fault positions and the reaction of the protection scheme, and we take now the medium fault as an example for the general logic how fault locating is carried out by means of overcurrent time protection. So this is our example, and we see the reaction of those protection relays. We have a start and a trip. And behind that trip there is no reaction at all. The reason is, after a fault there is no voltage on the line anymore, no fault current, not anything, and therefore this relay will not react. So we can see we have the sequence of yes, yes, yes and no. And in between we have this fault. So fault location can be carried out under one precondition, that there is no significant feedback current. So I thank you for your attention, and this was today's lecture about overcurrent protection, especially the chapter of selectivity and fault locating. Thank you very much.